effect in effect of gyroscopic couple in aeroplanes. Okay, so I'll show you the problem. So look at this. An aeroplane flying at 240 km/h turns towards the left and completes a quarter circle of 60-meter radius. The mass of the rotary engine and the propeller of the plane is 450 kg with a radius of gyration of 320 mm. The engine speed is 2000 rpm clockwise when viewed from the rear. Determine the gyroscopic couple on the aircraft and state its effect. In what way is the effect changed when the aeroplane turns towards right and engine rotates clockwise when viewed from the front and the aeroplane turns left and right? Right. So look at this. The is engine speed is 2000 rpm and rotates clockwise when viewed from the rear. Okay, suppose you are going to view from the front, the same thing will be in counterclockwise direction. Okay, so write the given data. So the data is given as r is equal to 60 meter, v is equal to 240 km/h, m is equal to 450 kilogram, and k is equal to 0.32 meter, n is equal to speed of the engine is 2000 rpm, and find the omega. Omega is equal to 2 pi n by 60. Okay, by using this relation you will get 209.4 radian per second. Okay, then the power, convert this into meter per second. How to convert this meter per second? By dividing this value by 3600. Okay, so that we'll get 66.6 equal to m k square. M is equal to 450 kilogram is given, and k is equal to 0.32, so it gives 46.08 kilogram meter square. Then omega p is equal to v by r. V we have calculated, it is given in the problem, it is given in kilometer per hour, we have converted it into meter per second. Then r is in meter. Okay, so that we will get 1.11 radian per second. Omega p as 1.11 radian per second. Then find the gyroscopic couple c is equal to I omega p. So I value we have calculated, omega and omega p value also we have calculated. By substituting this value we will get c is equal to 10.713 kilonewton meter, right? So now we need to find the effect of gyroscopic couple. Okay, while taking a left turn, and the aeroplane taking left turn, what will be the effect? Okay, so it is given from rear, it is rotating clockwise direction. Okay, so x to x dash, this is the active gyroscopic couple, this is in clockwise direction. And what about reactive gyroscopic couple? This is the reactive gyroscopic couple. So the reactive gyroscopic couple is same in magnitude of active gyroscopic couple but reverse in direction. Okay, so this is in counterclockwise direction. Okay, so apply this counterclockwise direction on the gyroscopic couple axis. Okay, so the gyroscopic couple axis is perpendicular to the screen. Okay, so by applying this counterclockwise direction, what will we will get? This side will move upwards. So what is this? This is a nose. This one is nose. So the nose will move upwards and tail will move downwards. So to raise the nose and to press the tail of the aeroplane. Okay, so this is the first case. And second one, and the aeroplane taking a right turn. Okay, for the same case, it is rotating in clockwise direction, and x to x dash is clockwise direction, So what about the reactive gyroscopic couple? This is just opposite to this active gyroscopic couple. Okay. So by looking from this end, you'll get this is in clockwise direction. Okay. So now apply clockwise direction in the axis of gyroscopic couple. Okay. Look at this diagram. Okay. Apply this clockwise. So what will happen? It tends to depress the nose and raise the tail. Okay. So the nose is depressed. Look at this. This depress the nose and raise the tail. Okay. So this raise the tail. Okay. The next case, while taking a left turn, when viewing from the engine is rotating clockwise when viewing from rear end, sorry, front end. So front end, we can convert this into anti-clockwise direction. Okay. So the same thing, I'll change with different color so that it will be easy to identify. So look at this, same thing, the aeroplane taking a left turn. This is rotating in counterclockwise direction. Okay. So this is in counterclockwise direction and the reactive gyroscopic couple is just opposite to this. So this is clockwise direction. Okay. So by applying this clockwise, what we will get? The nose is depressed and the tail is raised. Okay. For the same case, for taking while taking a right turn, it is rotating in counterclockwise direction. So x to x dash is counterclockwise direction. Sorry, clockwise x dash is counterclockwise direction, and the reactive gyroscopic couple counterclockwise direction. Okay, so now apply this counterclockwise direction on this gyroscopic couple axis of gyroscopic couple. I will get the nose is raised, tail is depressed. Okay, so that's all about this problem. In this way only we are going to find the effects of gyroscopic couple on aeroplane. Okay, thank you.